12.2a Conics, and we're going to be talking about parabolas today. All right, Mariah is going to be my nice reader today.
Conic sections were discovered during the classical Greek period 600 to 300 BC.
Long time ago.
The early Greeks were concerned largely with the geometric properties of conics. It was not until the 17th century that the broad applicability of conics became apparent and played a prominent role in the early development of calculus. A conic section, or simply conic, is the intersection of a plane and a double-napped cone. Notice in figure 2.9 that in the formation of the four basic conics, the intersecting plane does not pass through the vertex of the cone.
All right, that's what we're going to be dealing with today. Very nice. All right, so if we take a plane, two-dimensional surface, and we cut something, in this case, the double-napped cone. Well, it can form a circle. We've talked about those. We're going to talk about an ellipse when it cuts at kind of a slight angle. And then if it doesn't actually go through both parts of the cone, it's going to form the parabola. And that's what we're going to be talking about today. All right, if we cut it this way, straight up vertically, it'd be a hyperbola. Or if we kind of rotate that, it would also be a parabola or a hyperbola. We're not going to be talking about points, lines, and intersecting lines because you've done that for a long, long time. All right, so here's what a definition of a parabola is. And thank you so much, McKinley.
Parabola is a set of all points, x, y, in a plane that are equidistant.
Yeah, equidistant.
From a fixed line directrix and a fixed point focus not on the line.
All right, fantastic. I'd like you to draw out this picture. I'd like you to draw out that picture. And so this is kind of what we're going to be talking about today and tomorrow. So we have a parabola, but the parabola is shaped between a vertex and a focus, and the focus and the directrix. And so you can kind of think of it if you have a string that kind of is one string on the focus and another string that's on the directrix. These are going to be equidistant. Okay, so let's say the string goes out 2 units or something from the focus to this parabola. Well, guess what? It'd be 2 units to the directrix. In most cases, that's kind of how the parabola is formed. And so if we go from the vertex to the focus, that would be the same distance from the directrix to the vertex. All right, those are equidistant of one another. Right. I want you to write down, before we even get to the next page, is the distance between the vertex to the focus is going to be called P. All right, the distance between the vertex and the focus is going to be called P. All right, if you understand your P, you know everything. All right, you ever looked at your P? Anybody? No, you guys haven't really looked at your P? You should. What if it's too yellow?
You need to drink more.
You need to drink more. All right. You're dehydrated. All right. So you should have light tint of yellow. All right, light tint of yellow. Too dark yellow. Not good. Not good. All right. Talk about the standard equation of a parabola. And so I'd like you to write these two down. Okay, and this is where we're going to be spending our time today and tomorrow. So x minus h quantity squared is equal to 4p. Again, if you know your p, you got everything. Times y minus k. And that's when we have an x squared. And x squareds either open up or they open down. And then the other one we have is y minus k squared is equal to 4p times the quantity x minus h. And that's when we either open right or we open left. And again, if you understand your P, you know everything. All right, so once you got those two written down, I kind of want to talk about them. So to go to these pictures real quick. All right, so if you have an x squared, it moves up or it moves down, true? But if you know what your P does, your P is your distance between your what? Your vertex. No, don't say focus and vertex. Say vertex to focus. That means that's different. All right, because you're going to go backwards if you go the other way. So if your vertex to your focus, your P is positive, guess what? It goes up. All right? If you go from your vertex to your focus and your P is negative and it's an x squared, guess which way it goes? It goes down. All right. If we have a y squared and my P is positive, guess which way it goes? It goes to the right. And then if I have a y squared and my P is negative, it goes to the left. All right. So what is P again? Your distance between your vertex and your focus. All right. All right, so now we're going to find a standard equation of a parabola with vertex at the origin and the focus of 2, 0. I always encourage you to sketch these. It makes more sense when you do it. So if I have a vertex at the origin, what did that give me? 0, 0. Okay, so that's my H and that's my K. And then I have a focus of 2, 0. So which way did that go? If I have my vertex is right there and my focus is 2, 0, which way did it go? To the right what? 2. I moved to the right 2. And so there would be my focus. All right. And so which way is this parabola going to go? Up, down, left, or right? Right, because it's going to kind of go towards my focus. Remember those strings are kind of pulling it that way? That's kind of how I want you to think of it. All right. So there is my parabola. And that should kind of help us out in what we need to do. Now, I know this question doesn't ask for it, but I'm going to draw it anyway. And so my directrix would be going back here. Okay? And so we're going to be talking about that in a little bit. Well, now I need to solve for my P. If I understand my P, I got everything. So what is my P? My distance from my vertex to my focus. So what's my P? P equals 2. All right? And so now I'm ready to substitute it in my equation. Is this going to be an x squared or a y squared? It's a y squared. So now I have y minus, well, what's my y for my vertex? 0 squared is equal to 4 times whatever my P is. In this case, my P is 2. And then times x minus 0. And so now I'm just going to simplify it up. So I end up with y squared is equal to 8x. All right. So I want to go one more step. We finished what it's asking for on this problem, but I want to go one more step. What's my directrix? -2 is not an answer. Well, directrix is a line. So how do we name a line? This would be x equals -2. All right, -2 I will not give full credit. All right, I give halvesies. Okay, it's definitely not a point either. All right, so it's the line x equals -2. So I have a vertex at the origin, and this focus is 0, -2. Ma'am. Okay, so my P is -2. So which way is this going? Down. All right, good.
And then you use the formula and you do y minus 0 quantity squared equals 4 times -2 and then x minus 0.
Okay, so I'd have y minus 0, but this is, it's going to be an x squared, right? Because it's moving down. All right, so now I have x minus 0 squared is equal to 4 times my P of -2. All right, and then I'd simplify it up. So I'd end up with -8y is equal to x squared. All right, it's an x squared because it's going down here. Now, I want to also do my directrix. My directrix is the line what? Y equals 2. All right. Because again, it's equidistant. All right. 2, 4. Love it. All right. So that's going to be my focus. Okay, my focus is 2, 4, and I'm going to say my directrix. You want an x equals or a y equals, buddy?
X equals.
X equals what? Give me an even number.
2.
Okay, it can't be 2.
6.
6. I'm good with 6. All right. All right. So now I have a focus of 2 comma 4, and I have a directrix of x equals 6. And so what do I not have? I don't have my vertex. All right? I don't have my vertex, and I need to figure out which way it's going. All right? And so that's what I need to solve for. Well, let's start sketching. This will kind of help me out a little bit. 2 comma 4, where is that? Right 2 up 4. So there's my focus. And then my directrix is x equals 6. And what kind of line is that? It's a vertical line. All right, so there's my line, x equals 6. And so where would my vertex be? In the middle of them. All right, so my vertex is going to be in the middle right there. Well, what's the y value going to be on my vertex? It's got to be 4. All right, and in this case, my x value is also what? 4. Why is that 4 as well? Because it's in the middle of 2 and 6. So my vertex is actually 4, 4 here. Now, which way does this open? It opens left because it's going to hug towards that vertex. And that one went through, I promise. All right. And so now we need to get our p. And so what would my p value be here? What? -2. Because it goes from the vertex to the focus. All right. And so now I can write my equation of my line. Is this going to be an x squared or a y squared? A y squared. So now I have y minus my y, which is 4. I kind of wish they were different here. Whatever. All right, is equal to 4 times, what's my p? -2 times my x minus 4. All right. And so I'd simplify it up a little bit. So I have y minus 4 quantity squared is equal to -8 times x minus 4. Okay? All right. Of the parabola, y equals -1/2 x squared minus x plus 1/2. So we're going to have to do a lot of algebra in order to get all the focus, the vertex, the directrix. We're going to find everything. All right? So, just like when we started completing the square the other day, I need this a value to be what? I need that a value to be 1. So I'm going to have to start manipulating some things. All right? Before we even get going, what is this parabola doing? This is in the ax squared plus bx plus c form. But what is that parabola doing? We already know what that does. It's an x squared and it's a -a, so what's it doing? It's going down. So we need to make sure that whatever we do, we end up going down. All right? So anyway. Now, what do I need to multiply to get that x squared to be a positive 1? -2. So we're going to, before we do anything, we're going to multiply everything by -2. So now I'm left with -2y is equal to x squared and then plus 2x and then -1. All right. And so now we're going to start getting in and completing the square form. And so it's slightly different than what we did on Friday because now we have an equation instead. So now I'm going to say it's -2y, and I'm going to move this 1 over. And so now I have plus 1, and then I'm going to say plus blank is equal to x squared plus 2x plus blank. All right? Because what I add to one side, I got to do the other. That's an equal opportunity sport. All right? So then, how do I start completing the square? I take my b, which is 2, and then I divide by 2 and I square it. So what did I add to the right side? 1. So what do I need to add to the left side? 1. So on my right side, I'm left with what? X plus 1 squared. All right, and that was that practice that we did. And so on my left side, I'm still left with what? Good. All right. Now, do you see how I'm getting close to this form? I'm getting close. However, look at this coefficient of y. What is that coefficient of y in there? It's 1. Right now I have a negative 2. You following me? So what do I need to factor out on this left side? A negative 2. So that's what we're going to do. So now we have negative 2 times y minus 1 is equal to the quantity x plus 1 squared. All right. So now we could get our vertex. We could start getting our focus and our directrix soon. All right. And this is where I like to start sketching too. So what's my vertex right now? The other way. Negative 1, 1. All right. Because it's x minus. Okay. You see how it's x minus and y minus? All right. So my vertex is negative 1, 1. All right. And so this is where I like to start sketching. So what quadrant is that in? Second quadrant. All right. And then it's going to be an x squared, right? So it's either going to go up or it's going to go down. But what do I need to solve for? This will tell me everything. I need to solve for p. Well, negative 2 should be equal to what? 4p. So that's what I'm going to set equal. So now I have negative 2 equals 4p. And so how do I start solving for p? I just divide by 4. And so p equals negative 1/2. Well, if my p is negative 1/2 and it's an x squared, which way is this going to go? Down. So there would be my focus, and I'm going to open my parabola down. See how I did that? All right. So did that change the x value or the y value from my vertex to my focus? The y value. So my x value is still negative 1. And so what's going to be my y value if my p is negative 1/2 and it used to be a 1 for my vertex? It's just going to be 1/2. So there's my focus now. Now my directrix, remember, is kind of equidistant, but it's the other way. So I'd have a horizontal line just like that. And is that going to be an x equals or a y equals? That's a y equals. All right. And again, this is at 1. So my p is negative 1/2. So, and I add it. So what would I get? I get 3/2. So y equals 3/2. All right. Okay, so now I have x equals 1/2 times the quantity y squared plus 2y plus 33. All right, I'm going to start you out, and then I'm going to let you go for a little bit. What should we do first? Multiply everything by 4. All right, so let's multiply everything by 4. So now I'm left with 4x is equal to y squared plus 2y plus 33. All right. So now let's get it in completing the square form. All right, so I'm going to take my constant and move it over. And so now I'd end up with 4x minus 33 plus blank is equal to y squared plus 2y plus blank. All right. Go from there. All right. What do we do first?
Well, on the right side, you have to add 1.
So 2 divided by 2, and we square it, so we add 1, so we add 1. All right?
So then on the other side, you have to add 1 to make it even.
Okay.
And then you'd write it out as, on the right side, y plus 1 squared.
Good.
And then on the left side, you'd have 4x minus 32.
Love it.
So you have to factor the 4x minus 32.
So-
You get 4 times x minus 8.
Good.
So then from that, you can find your vertex, which is 8, negative 1.
All right, so our vertex is 8, negative 1.
And to find your p-value, you divide 4 by 4, which is 1.
All right. And so we take 4 is equal to 4p. So p is equal to 1. All right. And it's an x squared or a y squared here?
This one is a, what was
It's a y squared. So if my p is positive, which way is it going?
To the right.
To the right. All right. And so that's what we should be looking at now. All right. And so my focus would end up being 9, -1. And then my directrix would end up being
X equals 7.
x equals 7. All right. Hello.
Alright, so you get the focus by knowing.
So page 738, numbers 19 through 41 odd. Write that out, and then I want to do number 19 with you real quick. What do you notice about all of these problems? They're all what? They're all odd. Where do I want you to look? I want you to look at Calc Chapter. All right, we'll still go over board points. We will. 19, this is slightly different than what we've done so far, but it's not hard. All right, so we're going to be given these characteristics, and the vertex in this case is always at the origin. And so if my vertex is always at the origin, that already gives me my h and my k. Are you following me? So if I'm looking at number 19, does it give me my focus or my directrix? No, it doesn't. However, what does it give me? A point. And it's a point on the graph, which we know is we're going back to chapter 1, section 2, a solution. Okay, this is a solution. That's what a graph is. It's a solution set. And so I know my solution is 3, 6. All right. Now, is this an x squared or a y squared? It's an x squared. Because why? It goes up. All right. So now we end up having x minus 0 squared is equal to 4p times y minus 0, because I know my vertex is 0, 0. So now I'm going to substitute in my solution to solve for what? My p. So what's my x now? 3. So now I have 3 minus 0, which is 3. So now I have 3 squared is equal to 4p times y minus 0, which is 6. All right, so 3 squared is 9. Is equal to how many p's? 24 p's. So how do I solve for p? Divide by 24, so p is equal to 9 over 24, or it could simplify to 3/8. All right. Now, does it make sense that p would be positive here? Yeah, because which way is it going? It's going up. All right. Now, it doesn't ask for the focus or anything here. It asks me to find an equation. So this is where I'm going to just take this and substitute back in. All right. So now I'd end up with x squared is equal to 4 times 3/8 times y. Now, 4 times 3/8 could simplify to what? 3/2. So I'd have x squared is equal to 3/2 y. All right. Pretty good. If I wanted to, what would be my focus? 0, 3/8. If I wanted to, what would be my directrix? Y equals -3/8. All right.